Uh, I hope you can see the PPT, ma. Okay. Now we'll be going to the last part of the unit 2, Amma, which is nothing but relational algebra. And after that, you have got relational calculus. So these are the two topics which would be dealing with the theoretical part of your querying the database, querying the relations, the theoretical part of querying your relationships. Okay. Now we'll be working with first relational algebra over here. Then we'll be working with TRC, tuple relational calculus. And then we will be working with domain relational calculus. In short, it is called DRC. The first one is TRC, standing for tuple relational calculus. The second one is DRC, domain relational calculus. And as of now, we are going to work with something which is called as a relational algebra. So, going by the definition of relational algebra, it is a procedural query language. Relational algebra is a procedural query language that works on a relational model and gives a relation as an output. Okay, so relational algebra is a procedural query language that works on relations and gives relations as an output. Okay, so when I say relational algebra is a procedural query language, it means that the user is telling what data to be retrieved and how the data is to be retrieved. So the user is trying to give you a process of how or what data to be retrieved from a particular relation. Okay, that is the concept of your relational algebra. And talking about the different kinds of operations that relational algebra supports are given as follows, along with the symbolism used for each of the operations. So the first one is select, represented by your sigma. Then you have project, represented by pi. Then you have union, set difference, which are nothing but your set operators. You also have intersection. Okay. Then you have Cartesian product, rename operator. Whenever you are interested in renaming a relation, then you can use a rename operator. Then you have the concepts of joins, natural join. So this is the most important concept wherein you'll be trying to join two tables, two or more tables. Natural join you have, then you have left, right, full outer join. Left, right, full outer join. These are the symbolisms for all the three different joins. Okay, I'll be working with each one of these things with a sample example so that you can understand it easily. Then you have the concept of intersection, already I told you, and then division. So these are some of the different relational algebraic operations that we are going to work with. Different relational algebraic operators that you are going to work with. Okay, so the first one is select operator. The first one is select operator. It is denoted by sigma. Already I told you when I was talking about the operators, and it is used to find the set of tuples in a relation which satisfy a given condition. So whenever you are interested in displaying output based on the user requirements, then you're going to work with the concept of a select operator. Then you're going to work with the concept of a select operator. Okay, the syntax for select is sigma p within braces r. Sigma p within braces r. Sigma here stands for your select operator. P is the predicate or the condition which needs to be satisfied, and R is the relation. So it can also be written this way, it's up to you. sigma condition or predicate. Both are same. So predicate might be a condition over here, and from which needs to satisfy. Condition or predicate which needs to be satisfied from the given relation or table name. So this is the concept of your select operator. And how we are going to write a query is quite simple over here. So see, I have taken a customer table. I've taken a customer table with customer ID, customer name, customer city. Customer ID, customer name, customer city. Now, what I want you to do is I want you to display the details of customers who live in a city called Agra. Details of customers who live in a city called Agra. Okay. Now what I have to do? Sigma is the select operator. It is only for your theoretical purpose, ma. You are not going to execute this. So sigma is a select operator. Now, what was the condition I've specified over here is the customer city should belong to Agra. That is the reason I'm writing customer city is equal to Agra. Customer city is equal to Agra. From where I'm selecting the details is from the customer table. So select the details of the customer from the customer table. See, select the details of the customer from the customer table where the city of the customer is equal to Agra. So this is the way you're going to write a query. Okay. And the output of this would be these two rows. The output of this would be these two rows because Agra, the customer city, is present in two rows only. The customer city is Agra. That is the reason only two rows would be displayed. Now, if at all I say display the details of customer, display the details of customer whose name is Steve, whose name is Steve, then what I'm going to write here instead of customer city, I'm going to write name is equal to Steve. Select customer name is equal to Steve from customer. That will give you the details of the customer with name Steve. That will give you the details of the customer with name Steve. I hope this is clear, ma. Is it clear? Okay. Next, I'm taking one more example, ma. There is a student table. Assume there is a student name table with ID, name, and age as its attributes. ID, name, and age as its attributes. Janavi, could you stop messaging, ma? If at all you are not interested, you can leave the class because it's disturbing me. Or else you can leave the class, ma. I don't mind. Okay. Now see, I have an ID, I have a name, and I have an age, and I've written few values for all three attributes. Now, what I want you to display is fetch data for students with age more than 17. Fetch data for students with age more than 17. This is my question. So what I have to do is I have to use a select operator followed by the condition age greater than, what was the question? Okay, age is more than 17. Age greater than 17 from, now the name of the table changes, student. So select age greater than 17. This was the condition, and I'm writing the relation name. You can use all the logical operators over here. If at all you are working with multiple conditions, you can use the logical operators, not an issue over here. You can use and or whatever you wish to. You can work with that. But here I'm going only with simple statements, simple conditions rather. Okay, so select details of student whose age is greater than 17. Select age greater than 17 from the student relation. Now next question is return tuples from student with information of male students of age more than 17. So now what I want is, I want the details of the students who are male students and whose age is greater than 17. So both the conditions should satisfy over here. Now what I am trying to do is, I'm trying to make the simple condition as a complex condition. I'll write and, what is the, 1 second ma. So I don't have a gender over here, amma. I'll write ID is greater than 2. ID is greater than 2 and ID is greater than 2. So instead of gender being a male over there, since the gender is not placed in the columns of the table, I'm going with the student age should be greater than 17 and the ID of the student should be greater than 2. So I'm interested in picking up the rows or tuples from the relation where these two conditions are satisfied. Now, so 3 and 4. 3 and 4 is greater than 2, but 15 and 13 is less than 17. Hence, what will happen? The query would be resulting in a null set. That is, the two conditions are not satisfied. Hence, I'll be getting a null or empty set as a resultant. So this is with respect to your select operation in relational algebra with respect to simple condition as well as a complex condition. Okay, now, whenever you are interested in specific column values, then you use the concept of a project operator. Whenever you are interested in specific column values, then you go with the concept of project operator, which is denoted by a pi symbol. Okay, and it is used to select desired columns or attributes from a column. Okay, that is what I clearly told Amma. Whenever you are interested in selecting specific columns, not whole the columns of a table, then you go with the concept of project operator. And the syntax for project is pi a1, a2, a3 from a particular relation, where a1, a2, so on are the attributes and r is the relation. Okay, or you can go with the syntax this way. It's the same. Instead of a1, a2, I'm just going with the concept of column name 1, column name 2 from table name. Okay, now see, display the customer name and city. So what I'm going to work with is pi is a symbol for projection. Here you cannot work with selection now. Remember, selection displays all the 3 attributes. But here I'm only interested in selecting 2 attributes. Here I'm only interested in selecting 2 attributes. That is the reason instead of selection, I'm using a projection. So project, pi stands for project. What I'm interested in is customer name, customer city. From where I have to pick these 2 things is from the customer table. That is the reason I'm writing this. Okay. Project, customer name, customer city from customer. Now, instead of that, I'm only interested in customer ID. I'm only interested in customer ID. Then what I'll do, I can write the same query. So instead of customer name, what I'm trying to do is remove all this stuff from the customer table, customer underscore ID from customer table. And if at all I have to select all the three, I can write comma customer name, comma customer city, so on, any number of columns I can write. Now the second query is, I'm interested in displaying the name and age of a student. Interested in displaying the name and age of a student. Okay, I'm interested in displaying the name and age of a student. What I'm doing, project by name comma age from where, from the student table. So this is a minor difference between your selection and projection operation in your relational algebra. Select gives you the complete details based on the condition. Here you get the specific column values based on the user's requirements, and you can work with both the combination, as I've already done it in the query processor. While I was working with the query processor concept, if you remember, I can use project and select operations together also. Okay. Now next, I'm taking some two tables. I'm taking two tables. See, member is one, book is the other one. Member has member ID, name, date of birth. Book has book ID, name, author. Member has three fields, book has three fields. Member has three fields, book has three fields. Now, member IDs, I want you to display the member IDs of members who have borrowed books. Okay. So what I have to display? I just need to display the member ID from the borrow relation, which is not present over here. So what is happening over here is I need to create one more table. I need to create one more table over here. So that is your job. Okay, try to take this down, take this data down, all of you. Please, in the next two minutes, member book fields, you take it down, and based on the questions, you're going to write the answer. I'm removing the answers for you. Take these questions down. Just take the fields, that's enough. You have to create a borrow table. Already I've told you how you work with primary key as well as a foreign key relationship. So how you are going to work with the queries, you just try to analyze that. Note it down, all of you. That's fine, Janavi, but you could have done afterwards, right? Because all the messages I too am getting. Ma, have you noted down, ma, all of you? Yes or no? Okay, so you are going to answer all these three queries, ma. Based on the requirements of the table, you have to create the new table based on the fields required with respect to the questions. Okay, and why is the strength less today? Any idea, ma? CRs? This is the third query, Amma. Details of the members who were born on 21/10/1997. Details of the members who were born on 21/10/1997. Okay, fine, not an issue. Now, going with the next operation, ma. This is nothing but the union operation. Union operation. This operation is used to fetch data from two relations, two tables. And for this operation to work, ma, the two relations should be union compatible. The two relations should be union compatible in the sense that both the tables should have the same number of columns and they should have the same domain. They should have the same domain. Okay. One is there should be same number of columns and the other one is it should be containing the same domain. Okay. And the syntax for this is A union B. So whenever you have got two relations, A and B, the union of these two operations is given by A union B. So you can use the symbol capital U for representing the union operation. So I have two relations taken over here, ma. The first one is the account. The second one is the loan relation. First one is the account relation. Second one is the loan relation. So account has ID comma name and loan has ID comma name. Whenever you want to combine these two things, you're going with the concept of account union is the symbol for union loan. So what would this do is it will eliminate the concept of duplicates. If at all there are any in the two tables, it will eliminate the concept of duplicates. If at all there are any in the two relations, and it will display the values that are present in A, present in B, and are present in A and B. Okay. Now see, whenever I try to perform account union loan with respect to ID1, I'm looking with respect to ID1, 1A. First is 1A. So I've taken here 1A, then 1D is there with respect to relation loan. So I've taken that 1D because 1A is different from 1D. Both would be placed in the union of account union loan. Then I'm working with 2. I have 2A over here and 2B over here. Both are different. 2A is there, 2B is there. Both are different, so both are placed over here. 2A and 2B. Next, 3C and 3C, both are common. So I need to eliminate the concept of duplicates. Hence, I'm only working with 3C. Then I've got 4D and 4B. Both are different. So 4B and 4D. Okay. So 1A, 1D, 2A, 2B. 1A belongs to account, 1D belongs to loan. 2A belongs to loan, 2B belongs to account. 3C belongs to both the account as well as the loan. Hence, there is a duplication that would be only taken once. That is the reason I'm writing 3C only once. 3 is the ID, C is the name. I've just clubbed it over here in order to make it simple. Next is 4B. 4B is from the loan table and 4D is from the accounts table. So this is the way the union operator works. This is the way the union operator works. Then I have the concept of intersection in relational algebra. I have the concept of intersection. So intersection operation is denoted by inverted U symbol, and whenever I'm interested in selecting common rows, from two tables, then I use the concept of intersection operator. I use the concept of intersection operator. Okay. So let's say we have two relations R1 and R2. Again, I'm taking two relations R1 and R2. Both have the same columns, and we want to select all the tuples which are present in both the relations R1 and R2. Then we can use the concept of R1 intersection R2. Okay, now see, here I am taking two tables. The first one is course, the second one is student. The first one is course table. So this is the course table with course ID, student name, student ID. And then I'm taking over here student table, which has student name, student ID, and the student age as its attribute. I have taken some common data. Now, what I'm trying to do is project the students' names which are common to both the tables. Or display the student names which are common to both the tables. Now, what is happening? Since I'm interested in only name of the student, I'm working with project student name. From where? From course table. So this query would work. I get a relation. Then project student name from the student table. This query would work, and then I'm trying to perform intersection of both the relations. So what are the common names that are coming in both the tables would be Aditya, Steve. Steve. Anything else? Next I have Lucy. Aditya, Steve, and Lucy. Since Aditya may be repeated, if at all I go with intersection all, that would be coming 4 times. And C, sorry, 2 times. And C, whenever you want to work with intersection, you are not going to directly execute this query in your MySQL. You're not going to execute this query in your MySQL blindly. Try to understand that. Okay, now the next one is set difference. I'll give you more examples on these so that you can work on that. This is just for your understanding what is the syntax, and how we are going to work with each of the operator. Okay, Now, set difference is denoted by a symbol minus ma, or you can say dash. And whenever you are interested in finding out the tuples which are existing in a particular relation and which do not exist in another relation, then you are going to use the concept of set difference. It can be denoted by R1 minus R2 or R2 minus R1. It's up to you, whichever way you want. The things which are present in R1 and which are not present in R2, or the vice versa, reverse order. Okay, now I want you to display the list of student names. The list of student names which are present in student but not present in course. Which are present in student but not present in course. Then you go with the concept of set difference or the difference operator. So since I'm only interested in projecting the names, project student name from student, I'm using the set difference operator minus over here, followed by project student name from course. And the output of this would be this way. Student name, Carl and Rick. Carl and Rick. So this is the student table, ma. I'm going in the reverse order. Student table minus course table. Student table minus course table. So Aditya is there. It's present over here. Steve is there. It is present over here. Paul is there. It's present over here. Lucy is there. Lucy is present over here. Now, Carl, is Carl present in the course table? No. So Carl would be coming as one output, and Rick is also not present over there. So Rick would be coming as one more output. What is the output over here? So this particular resultant is the result of student minus course. You can also try for course minus student. It can be in both ways. Okay. Now just go through the different operators for 2 minutes, ma. If at all you have any questions, you can ask once. All of you go through the PPT once more. Which are present in one relation and which are not present in another relation. Try to work out on that. Shravya. So was any one of you able to create the borrow relation, ma? Borrow relation. Because two questions are based on the borrow relation. Any questions you have, ma? Any questions? All of you? What about the others? Okay, Amma. Next, going with Cartesian product. Okay, it is represented by the symbol X. And whenever you try to perform Cartesian product on two relations, whenever you try to perform Cartesian product on two relations, then the output of the Cartesian product would be combination of each tuple in relation R1 with each tuple in relation R2. So the output of Cartesian product would be combining each tuple of relation R1 with each of the tuples of relation R2. Try to understand this, ma. So if at all I say in a particular relation R1, I've got 5 rows, and in a relation R2, I've got 5 rows. Then R1 Cartesian product R2 is equal to 5 star 5 rows. I'll be having 5 star 5 rows. Okay, because what is happening over here is P1 of R1, meaning tuple 1 of relation R1 will be combined with P1 of R2, P2 of R2, I'm just writing it over here, Amma. P1 of R2, comma, P2 of R2, comma, P3 of R2, comma, P4 of R2, comma, P5 of R2. So what is happening here is P1 is combining with all the 5 rows of R2. T1 of R1 is combining with all the 5 rows of R2. T2 of R1 will also combine with all the 5 rows of R2. So on until I complete each and every row of relation R2. So in order to make it simple, I can say that whenever I'm applying the concept of Cartesian product over two relations, then the output would be the degree of R1 into the degree of R2. Or blindly, I can go with simple definition, the number of rows in R1 into the number of rows in R2. See, I'm taking a small example over here. I have a relation R1 with column A and column B. I've blindly taken two columns, column A and column B are two columns. And I've entered 3 rows for that. AA 100, BB 200, CC 300. I'm just working with 3 rows for table R1 and 3 rows with table R2. Now, whenever I'm working with Cartesian product, what would be my output is I'll be having a table with COL underscore A underscore A, the new table that is being formed, COL underscore B, COL underscore X, COL underscore Y. So my new table formed after I apply a Cartesian product would be combining the columns of table R1 and columns of table R2. And here beneath this, what will happen is AA 100, X6, 99. Okay, again, what will happen here is AA, sorry, Amma. X6 value is 99. And again, here I'll be having AA 100 followed by YY 11. So on, I'll be having the values. So the output is given to you in the sheet over here. What I'm applying is R cross S. R1 is R is the first relation, S is the second relation. So I told you the number of attributes in the new relation would be the number of attributes in the first relation along with the number of attributes in the second relation. So column A and column B are from the first relation. Column X and column Y are from the second relation. Now see, I had AA to be repeated twice because there are 3 rows in each table. So AA is clubbed with, this is the T1 of R2, T2 of R2, this is T2 of R2, and this is T3 of R3. Similarly, I have DBMS that would be repeated twice. Now, what is happening with the concept of Cartesian product is there is lot of data redundancy. There is a lot of data redundancy. And in order to work with this particular thing, we have gone with the concept of joints. We have gone with the concept of joints. In order to eliminate the problems caused by this, we are going to work with the concept of joints, wherein again we are trying to join two tables. two or more tables. That is the concept. So in the concept of joins, we will be working with natural join. We'll be working with natural join, left join, right join, full outer join. Left outer, right outer, full outer join. Okay. So this is what we are going to learn in our relational algebra. You have any questions you can ask? You have any questions in the class, Ma? You can ask. All of you, go through the PPT for 2 minutes. And if at all you have any. Yes, Ma, is it clear? Okay, CM, I'm working with the union operator over here. I'm working with union operator in your MySQL. So create table T5. ID comma name. ID integer comma name varchar of fine. Okay, and I'm working with creating table T6 with the same domains because they should be union compatible. Okay, so create table T5, ID integer, name variable character of 5, and create table T6, ID integer, name variable character of 5. Then I'm trying to insert the same data 1A, 2B, 3C, 3, 4D. Insert into T5 ID comma name values 1 comma A 2 comma B 3 comma C 4 comma D. Okay. So see, whatever I have used right now is if at all you are interested in entering multiple values or multiple rows in a table in a single go. Okay, what we usually do is we try to repeat this 4 times. But whenever you are interested in going with multiple entries for a table, then you can use it this way. Okay, Amma, is it clear? Insert into T5, you have to specify the column names in the table. Then you have to follow it with values. Then you have to enter the rows for as many rows as possible in your table. Okay. Now, what I'm trying to do is I'm trying to just modify this T6, 1D, 2A, 1D, 2A, 3C is common, 4B. Okay, enter this. This is also working fine. Select start from T5. I'm getting data and select start from T6. Okay. Now I have to perform union operation. Select start from T5, union, select start from T6. Okay. See, 1A, 2B, 1A, 1D, I'm not getting. Here I'm getting one. So what he's trying to do is, first he's trying to give the details of table 1, and he's not trying to give you the details which are repeated. You can look at the resultant mark. If at all you have any questions over there, you can just ask me. 3C is repeating in both the tables. That is the reason 3C is not being displayed twice. So this is the way you're going to work with union operator. Okay. Now, what do I do if at all I want to display the duplicates also? What do I do if at all I want to display the duplicates also? Does anyone have an idea? Union all, good. So instead of union, what I do is I write union all. So in the previous case, it was 7 rows selected. In this case, it is 8 rows selected. Okay. Fine. So try to understand the basic difference between union and union all. Whenever you are interested in only displaying the distinct things of two relations, then you are going to work with union. Whenever you want the duplicates in both the relations, then you are going to work with the union all operator. Okay. Now I can work with minus also in the same way. So select name from T5 minus select name from T6. you have an error. What is error? You have an error and check the manual error. What is the problem? Select name from P5. Okay, I'm getting this. I think minus is not working over here. Minus is not working over here, ma. So I have to look for another alternative. Okay, so see, some of the operators are not supported. I'll be looking over here. Intersection is also not supported. I told you check is also not supported, ma. Okay, in such cases, if at all some of the operators are not supported, you will be having different operators, ma. Then you have to work with the concept of left join, which will give you the things that are present in the left table and not in the right table. And you will be working with something called as right join. So right join gives you the concepts of the things that are present in the right table and not present in the left table. So you have to go with this, and I'll look at minus once more, ma. Okay. So as of now, is it clear, ma? How you have to work with? Directly, you're not going to work with selection and projection operator in your MySQL. You're going to work with joins. There you can say natural join, equi-join. How you're going to work with joins, what are the different kinds of joins, I'll let you know in the next class, along with working examples. Okay. Any problems, ma? All of you? So I'm starting the activities. If at all you don't have any issues. I've started with 3 activities, ma. You can work on the activities.